I'm dealing this semester is chemical reaction engineering. Earlier, the course was made into two parts. Like till your seniors have studied CRE one and two, but this year we have just reshuffled the syllabus and framed it as only CRE in the first semester, and then fluid solid reactions in the second semester. Okay, but the major content of the course in the second semester is comes under the CRE part 2 only, but it was just reframed and restructured the syllabus, keeping in point of view of adding some more core courses to your curriculum, because this R20 regulations has missing some core components, because we are reduced to 162 credits. Earlier it was from 216 credits. Now, because of the AICT model curriculum and as per the guidelines of APSCI and then UGC, so it was now brought down to only 162 credits. That means many of the core courses was missing in your curriculum. So yeah, for that, what I decided in the BYS meeting to restructure some of the courses such that at least some core components should not miss by the students. So in that part, the CRE course 1 and 2 has been rescheduled in one course, that is CRE. And then the second part of the course, which is also very important in perspective of the GATE examination, which was renamed as solid fluid reactions, and we kept it purposefully in the elective course. Though it was kept in the elective course, but we will certainly we will fix the course because that was very important for the GATE perspective. Right? Okay, leave about that. Let's start with the course. So the course is chemical reaction engineering. Can you close the door, Uma? Can you close the door? Yeah, keep it near. Yeah, that's near. That's near enough. Yeah, perhaps this may be my first course because in the previous semester I had to take the mechanical operations course, but because of this NBA accreditation purpose, I have not taken any single class also. Anyhow, that's leave. But this course we will take complete semester, and in fact, perhaps I may take the second part of the course also in the next semester. Now, let's see chemical reaction engineering. Why we want to study this course, and what is this in this course? Why the name has come? What is chemical reaction? What is chemical reaction? You're saying so many chemical reactions, na? When you woke up in the morning till you go to sleep, you are seeing lot of chemical reactions, is it not? Lot of chemical reactions you are observing. Maybe start with the photosynthesis reaction. What is photosynthesis reaction? Carbon dioxide, water, in presence of sunlight, will convert into glucose and then the liberation of oxygen, which we are inhaling. Fine. That's a reaction. Is it a chemical reaction or not? Is it a chemical reaction or not? Then what is a chemical reaction? See, being the engineers, we should first define anything we have to define professionally. Being an engineer, we should have to define professionally. Chemical reaction. I ask you for a definition. Chemical reaction. For example, if I write like this, A plus B gives rise C. Is this a chemical reaction? So that A may be something, B may be something, C may be something. Usually we call A and B are reactants and C as product. Okay. Now I should have to know what is a chemical reaction. Now what is a chemical reaction? If you what are the left hand side part of the arrow mark are called reactants, in our perspective till maybe 10 plus 2 stage, and what are there on the right hand side mark are the products. No, these reactants are reacting. Then only the reaction proceeds to form a product, and ultimately the complete sequence is called chemical reaction, which we are saying. Now we have to define now. Now how do we define? See, this A, B are reactants we are supposing. Reactants, components, molecules, atoms, whichever it may be, those are called entities. Those are called entities. For our simplest, we are calling as a reactants because we have a notion in first two stages that arrow mark besides are called reactants. Right hand side part of the arrow mark called products. Fine. So how should I define a chemical reaction? Any entities, any entities are interacting to form some product. So that sequence is called a chemical reaction. So the interaction of entities. So what are the entities? That entities may be atoms, molecules, chemicals, whatever it may be. Those are called some entities. They are interacting. They are reacting. And the complete sequence is called chemical reaction. Okay. So we are seeing so many chemical reactions in daily life. Best example I said you is photosynthesis. Fine. What is photosynthesis reaction? CO2 plus H2O in presence of sunlight gives rise C6H12O6, that is called glucose or sugar molecule, plus O2. We can balance it. That's called a photosynthesis reaction. It's a chemical reaction. Now, any other reactions in daily life? Rusting of iron. Iron rust or not? So, what is the reaction? Fe oxidages. Fine. So, Fe plus O2 plus H2O gives rise Fe2O3. Oxidation form of iron is called iron. That's also a chemical reaction. So in daily life, we are seeing lot of chemical reactions. Fine. Now we need to engineer. We need to engineer the chemical reactions. That's called chemical reaction engineering. Now, what do you mean by engineer? Why do we need to engineer the chemical reactions? Why do we need to engineer the chemical reactions? Best example, you might have seen the Bhopal gas tragedy. You might heard, right? Though you may not have seen, but you heard. What is the cause for the Bhopal gas tragedy? Release of methyl isocyanate. That's the main cause. So this methyl isocyanate, when it's released in the reactor because of high pressures, it has reacted with water. And then what happened when it is reacted with water? Methylamine has released. So that vapor plus carbon dioxide gas has been read into the areas in and across the that whatever the industry. So what happened then? That has been inhaled by so many people across the industry. What happened then? Several people have died. That's all. Anything else? Methyl gas leakage in Bhopal gas plant. Anything else? Anything else? People have died. We know there is a big tragedy gone. There is a big law has gone. Even in fact, it has gone to the prime minister. You know who has the industry led? United Carbon (UCI). That complete managing director has been gone to foreign states because he has been kept under the sun, so he has been left, and our people has been thrown away him. There's some big logic has been gone for over a decade, and it's not the death of the so many people for the release of methyl isogas cyanide, but there is no still the fertility in that land. There is no fertility, and kids who have born till date born with the diseases only because that the traces amounts of the gases or the vapors has been added in the soil itself, soil and water and air. So that's why it has been demarcated. That complete industry has been demarcated and put it as like a museum. And every year on that day, school children will go and visit that industry. It's like a movie theater where the people will come and see and then go. So that much of demarcation they have kept means that much of tragedy has happened. Now, why I said all these stories? There is a reaction called methyl isocyanate plus H2O gives rise methylamine plus CO2. That's a big chemical reaction. Where that has led to this much of big disaster. Now, why I am saying this reaction is I need to engineer the chemical reaction. I need to engineer. I need to engineer means I need to control. Otherwise, what happened? This type of reactions may happen in the future also. There are so many reactions every time we are seeing explosion of chemical reactions in the industries. So why that explosion has taken place? There is some reaction is going on, and being an engineer, we need to control. Sometimes we need to increase, sometimes we need to decrease. Fine. That's called engineering. So you need to engineer means you should understand first the chemical reaction, why it has happened, when it will happen, how to increase, how to decrease, how to control. If I want to control, I should understand what is the flow rates, what is the temperature, whether it is exothermic or endothermic, if there is heat is liberated, what is my material construction, what is my reactor design. I need to think all those things. That's called all the engineering. That's all called engineering. Being an engineer, perhaps especially chemical engineer, we should understand the chemical reactions clearly. When you understand chemical reaction clearly, then only you can think of how to control, how to manipulate, how to increase, how to decrease. Is it not? We need to increase or not chemical reactions. Definitely. For example, I need to produce ammonia. What are the components for production of ammonia? So I need to take nitrogen, I need to take hydrogen to form ammonia. Fine, balance it. So if I want to produce ammonia, I need to add nitrogen and hydrogen. I always want to increase the yield of ammonia or urea or phosphorus or sulfuric acid, which not maybe I want to increase. So sometimes I have to think of chemical reactions to be at a good pace, at an increasing trend. Sometimes I need to control, decrease. The case of methyl isocyanate, I have to stop it. For example, rusting of iron. Can I increase or decrease? Rusting of iron. Who wants rusting of iron? No one wants. But it's a natural phenomena. Iron always gets corroded. Whenever iron reacts with water molecule, certainly small amount of oxygen is available. Definitely it will get corroded. It will form definitely iron oxide. No one will stop. Even God will not stop this reaction because it's thermodynamically spontaneous reaction. But being an engineer, you need to control the reaction sometimes, increase the reaction sometimes, decrease the reaction sometimes, manipulate the reaction sometimes. Fine. So this course deals with completely the engineering of the chemical reactions. Clear now? The title of the course, Chemical Reaction Engineering. The reactions, that is the interaction of the entities, engineering the reaction of entities. It's called chemical reaction. Okay, let me start with few examples so that you will master the course. You will enjoy the course because beautiful. It's a beautiful course where we have modeling concepts, where we have problems, where we have conceptual theory that will be lifelong led to your career. Let me start with one good example. So you might have heard about the Coca-Cola. Fine. So what is the Coca-Cola company manufactures? Beverages, cool drinks, soft drinks. Fine. Soft drinks and our soft drinks card. These soft drinks, okay. Fine. So why people like Coca-Cola? Coca-Cola is the number one brand in all soft drinks compared to other brands. See, there are parallel companies, competitors. Pepsi undi, Sprite undi, ఇంకోటి ఉంది. But Coca-Cola always stands ahead. Can you say why Coca-Cola stands ahead compared to other brands? See, every soft drink is sweet only. Then why we go for only Coca-Cola? The thrill, why? Chill, chill. Why? Are you not getting same thrill when I open a Pepsi bottle or a Maja or a Sprite? Why Coca-Cola profits are marginally higher than other brands? Maybe across the globe, not in India, maybe across the globe. The one reason is the Coca-Cola company brands up this idea of soft drinks with high fructose corn syrup. Have you heard about this HFCS? High fructose corn syrup. What is this high fructose corn syrup? See, you might have a notion that every soft drink has sugar because we want sweet. What is the cause for the sweet? Sugar. Naturally, we thought there is some sugar is added, so that is what I'm getting the sweet. Sometimes some fragrance, some color, some something etc. are added to get some flavor or the thrill which you want. Fine, but that was wrong. There was no sugar added to the soft drinks. If there no sugar added to the soft drinks, how do you get the sweet? How do you get the sweet? Soft drinks are sweet or not? First of course, they are sweet only. But without adding sugar, how do you get a sweet? By adding this syrup. This syrup is called high fructose corn syrup. So this concept of this high fructose corn syrup has taken up by this Coca-Cola company, and in fact, it has marginal profits because of the chemical engineers in the company. You may be surprised. What is the role of chemical engineer in the Coca-Cola company? But it's a big role of chemical engineer in the Coca-Cola company. I tell you the reason. Just look at what is this high fructose corn syrup. It's actually this high fructose corn syrup. Have you know what is sucrose? What is sucrose? Sucrose is sucrose is a combination of glucose and fructose. There is a small linkage between bond between glucose and fructose. So almost a mixture of glucose and fructose is called sucrose. Fine, 50%, 50%. Let's assume. Do you know the structure of glucose? Now, if you look at maybe in 10 plus 2, there's a big chain where you have H, OH. Okay, there is a H, OH, and there is a OH here and then H here. Fine. And there is a C double bond O, and there is CH2OH, and then there will be CH2OH. And almost similar to is instead of C double bond O, you have here CH2OH and then HOH. And remaining else is same. And if you look at the molecular structures, these are called isomers. That means same molecular formula. Molecular formula is same. C12 H22O11. Glucose is also C12H22O11. Fructose is also C12H22O11. But what is the difference is they are isomers, but only difference occurs is the functional groups. Just functional groups. This if the CH2OH comes over here, this will become fructose. And the C double bond comes, this will become glucose. The only fundamental difference between glucose and fructose. Fine. The molecular formula is same. I'm saying the molecular formula is same. What is the difference is arrangement of the atoms. If the C double bond O comes here, this will become glucose. If it comes here, this will become fructose. Irreversible. So this glucose is almost 42% and this fructose is almost 50%. If I take any sucrose or a sugar, that's what I'm talking about. Now the reason is this fructose is much sweeter than this glucose. This fructose is much sweeter than this glucose. Now, this fructose cannot be alone. It is combined with glucose because sucrose contains glucose and fructose. They have been combined. They have been combined. But fructose is much sweeter than glucose. That means what? I do not want glucose. Though it is combined, I do not want glucose because that is not giving good taste. Only sweetness causing component is fructose. Fine. But this is combined with glucose only. Glucose is combined with fructose only. I do not want the glucose because compared to fructose, fructose is much sweeter than glucose. Clear now? Now, being a profit venture, I always think my component should be fructose alone rather than glucose because that is the good sweetening or sweetener compared to glucose. So if I take any sucrose, if I could convert this glucose into fructose, I'll get good yields. Is it not? Because glucose is ultimately 42%, which is not useful for me because that is not giving good taste, good sweet compared to fructose. And fructose is in fact 58% more component. If I can convert this glucose completely into fructose, my sweet causing component is increased and I am getting good profits. Because what is the difference glucose and fructose? Only this arrangement of atoms. If I rearrange, I'll convert this glucose into fructose. So the isomerase which converts glucose into fructose is glucose isomerase. This is an enzyme. This is an enzyme which acts as a catalyst to convert glucose into fructose. Now, who will do this job of conversion of glucose to fructose? Only chemical engineer. Because chemical engineer only will think of catalyst, will think of a platform, will think of a support where this reaction will happen. So this chemical engineer only can prepare a support of layer where the reactants will sit, catalyst will influence the reaction, completely conversion of glucose to fructose. This job done by only chemical engineer. Because if there is no chemical engineer, this reaction will not happen. If this reaction will not happen, I will not get good fructose yield. If there is no good fructose yield, I cannot prepare this high fructose corn syrup. If there is no high fructose corn syrup, I will not get good profits. So ultimately, the Coca-Cola company has been led by the chemical engineer team, where the role of a chemical engineer is to use a catalyst for this reaction of conversion of glucose to fructose. Understood? Understood. So what exactly the chemical engineer role here? What is exactly the role of a chemical engineer? In this particular case of a Coca-Cola, particular case, the role of a chemical engineer is to make a support because for any reaction you need a support. Where this reaction will happen? Where this reaction will happen? There should be some support. For example, you are doing some lab in your experiment. There should be some beaker. There should be some vessel where you add some reactants. That means you are creating a space, a place or a space where reactants will come, sit, react together to get a product. So this entire platform has been created by only chemical engineer. He will think of this enzyme. How should I master that enzyme? How should I pick the enzyme? How should I activate the enzyme to get involved in the reaction to form glucose into fructose? No one will do except a chemical engineer. Understood? So what is here the chemical engineer is doing? He is understanding completely this reaction sequence. For example, if there is no chemical engineer, let's assume for some time, so there is no reaction here. So all the soft drinks should be only sugar added. What will happen if all the soft drinks should be sugar added? Every rich people who drank the drinks will be diabetic patients. More diabetic centers. But that is not the case. People are happily chilling with Coca-Cola bottles because there is no sugar added. There is a corn. You know what is a corn? Corn, mokkajonna. So this corn which contains the sugar, containing the glucose and fructose has been converted. So the sugar has been derived from the corn. Corn, not cane. Cane sugar is different, corn sugar is different. So corn, which is also agri waste. So I am getting sugar syrup from the car by using this simple chemical reaction understanding. So a deeply engineer will understand this reaction. If I don't understand this reaction, I never get that syrup. Only chemical engineer understand this reaction. Clear? The second example. So have you heard about thalidomide? Thalidomide. Have you heard about thalidomide? Thalidomide is an important drug used to stop the vomitings for a pregnant woman. Thalidomide is an important drug used to stop the vomitings, nausea. For a pregnant woman, first 3 to 4 months, women will get more vomitings. So doctors will prescribe this medicine to arrest these vomitings. Now, what is this drug? This drug, if you look at the structure of this drug, it actually has two racemic mixes called R and S forms, like glucose and fructose. Two structures, both are similar, molecular formula is similar, but only slightly variation of the atoms. This drug, almost like we draw the glucose and fructose. What is the difference in glucose and fructose? Entire structure is same, only the C double bond goes here. If it is gone up, it will form fructose. Or CH2O in fructose, if it is come down, it will become glucose. Only arrangement of the atoms. That's the only difference. Fine. Here also, this drug has two isomeric forms, R and S, wherein the difference lies in only slight arrangement of the atoms. Now, why I'm talking about this drug particularly? Because this drug has been banned. Why this drug has been banned? Because it's a very famous drug in 1950s. Almost 1950 to 1970, this was drug was sold by companies like anything. But very unfortunately, this drug was banned till date. Because the reason is, as I said, two forms are existing for this drug. This R form very active in controlling the vomitings, but this S form is creating the side effects. Means people who have taken drug, it's born with multiple diseases, disorder diseases, bone fractures, cancer. Now, doctors should identify which form of this thalidomide drug is acting to the human body. Otherwise, what will happen? I simply prescribe thalidomide to a patient, and this drug has two forms. If I don't understand which form is acting perfectly or drug side is going to target the component where I am getting the problem, that's fine. If that is not the case, maybe very unfortunately instead of R form, if S form is active, so the patient who has taken the drug will get kids with multiple disorder diseases. This complete drug has been banned. Now you tell me, what is the role of chemical engineer here? So the role of chemical engineer is here to understand which forms are there, which structures are there. Can I form this inactive S form to R form, or can I isolate completely? Can I isolate so that only R form is available? Chemical engineers can tell. Either convert S form into R form or simply isolate the S form, remove that S form, only R form is active. So drug is 100% active towards arresting the vomitings. Clear? So the role of engineer here, that's what I'm talking about, the engineering. So I should engineer, control, I should manipulate, I should stop, I should prevent, I should take some measures. When I do all these things, if I master the chemical reactions, if I understand the chemical reactions very notionally, fundamentally, what are my molecules, how they are reacting, what are the mole ratios, all I should understand. If I master it, I can engineer. I can engineer. That's for the second example. Maybe look at a third example. You might have everyone are using the perfume. Fine, everyone are using the perfume. Now, when I just open a perfume here, the moment I open, the last bench person will get that smell. How it has happened? Diffusion. Very good. Very good. So the molecules which this perfume contains, maybe ethyl alcohol or some oils, volatile oils, when I which are in the compressed state, when I open it, it forms into gaseous phase, quickly diffuse to the other end. Now my question is, who asked these molecules to go there? Who asked? Is I asked to go there? Why they have gone? Why the last bench person has inhaled and said very beautiful perfume, sir? Who asked? It's the gradient. It's the driving force. Might have in master answer you will get this concentration gradients, chemical potential. So fundamental driving force is the potential. So that comes under thermodynamics. I'm not bothering about that part. Just leave about it. I'm talking about when I open a perfume bottle. So there is a some chemical reaction. Is it not? So when I open it, whatever the molecule in my perfume gets quickly diffused into the react with air molecules and quickly diffuse to the other ends. Is it not a chemical reaction? Or when I just cut an onion, I'm getting tears. Why? You might have seen when I cut an onion, I'm getting simply getting tears. Usually, women knows that. Why? Because there is again a chemical reaction. The sulfonic acid, which gets into the ears, form beta S form. So that leads to tears in our eyes. So from morning we will go to sleep. There are chemical reactions happening in the nature, but knowingly or unknowingly we are just skipping and not understanding perfectly. But if you leave it, it's not an issue because everyday day to day life. But in the industrial perspective, if you leave, tragedy will happen. Bhopal gas tragedy. You cannot leave as it is. So when you talk about an engineer in an industrial perspective, you cannot leave as it is. You have to understand the reaction. You have to understand the mechanism. You have to understand the complete parameters, design principles. Then only you can safeguard or safely protected. Otherwise, you along with the people who are in that industry will ensue, has to leave the life. Clear? Clear? So the importance of the course. I just discussed about the importance of the course. Why we need to study the chemical reactions engineering? Because what is the reason of studying? Bhavna, why we need to study chemical reaction engineering? Just sit and tell. Why we need to study chemical reaction engineering?
Make sure harmful happens, people or the society, in equipment making or in design making.
The basic principle is we should understand first the chemical reaction. Is it not necessary? We should understand first. Without understanding, we cannot do anything. We cannot increase or decrease or cannot stop. We should understand the chemical reaction. So the first part of the course is Unit 1 contains the basic fundamental understanding of the chemical reaction engineering. That means we study the basic principles. What are the components? How many types of reactions are available? What are the variables affecting the chemical reaction? Is it not any chemical reaction is being affected by variables? Any chemical reaction is affected by the variables? Of course, for example, take a case of rusting of iron. When will be rusting of iron will be predominant? Rainy season. Is it not? Rainy season. Why in rainy season the rusting of iron is predominant? The available of water molecules are more. For iron, if water molecules are available, small amount of oxygen is available enough. Iron quickly reacts with water molecule with oxygen to form iron oxide, hydrated form of iron oxide, brownish in color. So that is predominant in rainy season. That's why in rainy season all electrical poles, railway staggers, railings, all will be get corroded quickly because plenty of water molecules available in rainy season, plenty of humidity, plenty of moisture. So is it not variables affecting? Here the variable is humidity, water. So similarly temperature. Temperature is also another variable. Is it not? Some of the reactions are influenced by temperature. If I increase the temperature, sometimes the yield is more. Is it not? What is the reaction for ammonia? N2 plus H2 gives us ammonia, 2NH3. Do we need a catalyst here? So it's a catalytic reaction. So we need some iron. We need a catalyst here. So sometimes some of the reactions are influenced by temperature. If I increase the temperature, it's getting increased like anything. So we need to understand the variables affecting the reaction. So all will comes under the unit 1. So that is what the course, the engineering of all the chemical reactions we will study in this course. Okay? And perhaps the main part we focus in the first part in CRE is the kinetics. Complete course is focused on the kinetics. So what is kinetics? We will come across. We will come across. So don't worry. Now let me classify the chemical reactions first. Now understood the chemical reactions. Fine. How do we classify the chemical reactions? Chemical reactions have been classified into two categories. Homogeneous, very good. So what is homogeneous? What is heterogeneous? Yeah, homogeneous. So if any reaction has been carried out or has been taken in single phase, in single phase. So that single phase may be solid phase, liquid phase, or a gaseous phase, whichever it may be, but it should occur in only one single phase. That's called homogeneous reaction. Now give me the examples. Yes, he said something N2 plus H2 gives 2NH3 as a homogeneous reaction. He has given. But that was wrong. That was wrong. Why? Nitrogen is gas. Hydrogen is gas. Very good. Ammonia. So two phases have been come. So that's not a homogeneous. It comes under the heterogeneous. Now what is an examples for homogeneous now? H2, H2 plus O2 gives rise. Probably you can balance it. This is also not homogeneous. Why? Hydrogen is a gas, oxygen is a gas, H2O is C plus O2, very good. Let's take the C plus O2 gives rise CO2. What is carbon? Solid. Buggantam. Carbon is buggu. Solid. Oxygen is gas. CO2 is gas. Again, two phases has come. How it is homogeneous? చాలా ఎగ్జాంపుల్స్ చూస్తున్నాం రోజుకి. CO, very good. That's called combustion reaction where carbon monoxide reacts with oxygen to form carbon dioxide. All are in gaseous phase. That's a very good example. So sometimes combustion reactions comes under the homogeneous reaction. Any other example? So very good. So the example is for homogeneous CO maybe plus half O2 gives rise CO2. Yeah. Any other example? All are in one phase only because I have defined homogeneous as single phase reaction. Any other example? Tell me the reaction. Don't say crudely. Say which organic reaction. Maybe boys answer well. Boys have a lot of experience. So alcohol, when I mix with water, alcohol in liquid phase, water is in liquid phase, I'll get maja. Both are liquid phase only. Fine. So a mixture of alcohol and water, leading to chemical reaction is a homogeneous. In fact, maybe you know or not, I don't know. Perhaps you might know. Why people will like maybe the beers or wines who has been spent for a year or half year? Do you know the reason? బాగా మురగబెట్టిన అంటే బాగా పెట్టిన ఉంచిన బాటిల్స్ ని మంచి కిక్ ఎక్కుతుంది అంటారు. ఎందుకు తెలుసా? పదో క్లాస్ పిల్లడిగా ఆన్సర్ ఇవ్వకండి. నాకు ఏదైనా ఇస్తే టెక్నికల్గా ఇవ్వాలి. మేబీ ఫెర్మెంటేషన్ మే బి ద రైట్ ఆన్సర్, బట్ ఐఎమ్ స్టడింగ్ అబౌట్ కెమికల్ రియాక్షన్ అండ్ ఐ వాంట్ ద కెమికల్ రియాక్షన్ బిహైండ్ దట్. What is that ethanol has been reacting with oxygen to form vinegar or acetic acid, that is called breverated alcohol, which gives a bitter taste for sparing for longer times duration. ఎక్కువ కాలం బాటిల్స్ నుంచితే ఆల్కహాల్ స్లోగా ఎసిడిక్ యాసిడ్ కింద కన్వర్ట్ అవుతుంది. వినిగార్ అంటాం, అమ్మాయిలు తెలిసే ఉంటుంది. వినిగార్ హ్యాస్ లాట్ ఆఫ్ అప్లికేషన్స్. That vinegar it has converted. If you keep the beer bottle or wine bottle for longer times, that gives a different taste rather than taking drink at the day when you manufacture. ఈ రోజు తయారు చేసిన వైన్ ని బీర్ ని తీసుకుంటే టేస్ట్, ఆఫ్టర్ 6 months అదే బీర్ ని వైన్ తీసుకుంటే టేస్ట్ రెండు డిఫరెంట్ గా ఉంటుంది. ఎందుకంటే కెమికల్ రియాక్షన్. The spent alcohol has been reacting with water or oxygen and it's been converted into vinegar, stick acid. సో మనం ప్రొఫెషనల్గా ఆన్సర్ ఇవ్వాలి. పదో క్లాస్ పిల్లలు ఆన్సర్ ఇవ్వకూడదు. మేబీ ద ఫర్మెంటేషన్ ఈజ్ కరెక్ట్, బట్ యూ షుడ్ సే ద రియాక్షన్ ఇన్వాల్వ్ హియర్. ఓకే, చెప్పాను. ఇంకా ఏమైనా ఉన్నాయో? హోమోజినియస్ మాట్లాడుతున్నాం. సింగిల్ ఫేజ్ లో జరిగే రియాక్షన్స్. 2SO2 gives rise sulfur trioxide. Very good example. Sulfur dioxide react with oxygen to form sulfur trioxide. Any more? సింగిల్ ఫేజ్ లో జరిగేవి. O2 ozone, maybe correct. Anything else? సింగిల్ ఫేజ్ లో జరిగేవి. Most of the liquid phase reactions are homogeneous reactions. అదే బెస్ట్ ఎగ్జాంపుల్ చెప్పాను కదా, ఆల్కహాల్ వాటర్ రెండు లిక్విడ్ ఫేజే. సో మోస్ట్ ఆఫ్ ద liquid phase reactions are homogeneous reactions. Only very few gaseous reactions are homogeneous. Very few. Very few. SO2, C plus half O2. So very few reactions are homogeneous. Now comes to the heterogeneous. What is heterogeneous? More than one phase involved. All are one phase involved. You see ammonia, gas and solid. You see carbon dioxide, gas and solid. Gas and liquid. Liquid and gas. Or all the three. Best example is ice cube. Best example is ice cube. So ice cube when it taken from the fridge, if I kept on the table, initially it is in solid, but slowly it will become liquid, sometimes vapor. All the three phases exist. So heterogeneous. Okay, fine. Any more examples for heterogeneous? A lot of examples for heterogeneous. Ammonia synthesis, nitric acid synthesis, sulfuric acid synthesis, all are heterogeneous only. Fine. All are heterogeneous only. Photosynthesis reaction, very good. Rusting of heterogeneous. Rusting of iron heterogeneous only because iron solid, oxygen gas, water molecules liquid to form iron oxide solid, multiple phases involved. In fact, soap. How do you get soap? Soap. Saponification we call. Saponification. Alkali reaction with fatty acid leading to formation of soap. Heterogeneous reactions. So there are so many reactions in our day-to-day life which fall under either homogeneous or heterogeneous. That means either they occur only in one phase or sometimes occur in multiple phases. Sometimes reactions occur in the interphases of the two phases. Okay, fine. So or anything else in day-to-day life we will see. No reactions. No reactions. Okay, when you come to the next class, so try to recollect, recollect. Maybe you can think or you can Google it. List out all homogeneous reactions. List out all heterogeneous reactions. Okay, list out all homogeneous reactions. List out all heterogeneous reactions. When you come to the next class, fine. So I'm stopping here. Okay, I'm stopping here. So in the next class, directly I will enter into the unit number 1. So unit number 1 means I'll start the basics of the course. Today I have not started anything. I just given overview of why we need to study, why we need to study, and what we get after. Ultimately, after end of the course, after reading completely the chemical engineering, there should be something to me. So that is what I told you now. కోర్స్ అంతా అయిన తర్వాత ఎందుకు చదివాను అనిపించుకోకూడదు. చదివితే నాకేమొచ్చింది, దాన్ని నాకు ప్రయోజనం ఏంటో ఆలోచించాలి. సో ఈ కోర్స్ చదివితే ఏ రియాక్షన్ అయినా కంప్లీట్గా అర్థం చేసుకోగలుగుతాను. కంట్రోల్ చేయాలని ఒక మైండ్ సెట్ వస్తుంది. ఎందుకు కంట్రోల్ చేయాలంటే కంట్రోల్ నువ్వు చేయాలి. ఇంజనీర్గా నువ్వు చేయాలి కంట్రోల్. నువ్వు చేయకపోతే నువ్వు ఇంజనీర్ కాదు. ఒక షిప్ కింద సింక్ అయిపోతుంది అనుకోండి, ఎట్లా నువ్వు కంట్రోల్ చేయాలి షిప్ని? ఆ షిప్ సింక్ అవడానికి రీజన్స్ ఆలోచించాలి. షిప్ సింక్ అవుతుంది అంటే ఎక్కడో ఒక హోల్ వస్తుంది. హోల్ ఎందుకు వచ్చింది? కరోడ్ అవుతుందా? కరోడ్ అయితే ఏ రకం కరోడ్ అవుతుంది? సోడియం క్లోరైడ్ కంటెంట్ ఎక్కువ అక్కడ ఉండొచ్చు. సో ఏంటి రీజన్? నేను ఎట్లా డిజైన్ చేస్తే షిప్ సింక్ అవ్వకుండా ఉంటుంది, లేదా బ్రిడ్జ్ కొలాప్స్ అవ్వకుండా ఉంటుంది? అర్థం చేసుకోగలిగితే మనం మెజర్స్ ఆలోచించవచ్చు, థింక్ చేయొచ్చు. అర్థం చేసుకోకుండా ఉన్నామనుకోండి ఏమి చేయలేం. సో దిస్ ఎంటైర్ కోర్స్ will talk about that only. How do we master the reactions? How do we control some of the chemical reactions? We need to understand the mechanisms. That's all this course. Okay. I'll start unit number 1 directly in the next class. Okay. So when you come to the next class, just fair it up. What are the examples for homogeneous? What are the examples for heterogeneous? Okay.